This video will discuss a fluid phenomenon called a hydraulic jump. A hydraulic jump can be seen in homework problem 5.123 and can be found in real life in rivers and free flow channels throughout the world. These jumps can be fun and entertaining for experienced whitewater rafters. However, they can be incredibly dangerous for beginner rafters and kayakers.
In some instances, the current falls back onto itself and creates a dangerous recirculating current under the surface of the water. This type of flow is known as retentive or recirculating. If a person falls into the water or flips their kayak near this retentive hole, they can be trapped underneath the surface of the cyclically moving water. The water repeatedly cycles over the person, pinning them in the current beneath the drop, often leading to drowning. This video will detail the incredibly interesting physics and fluid mechanics principles behind these phenomena, and will discuss actions that can be used to make waterways that contain these types of currents safer.
We aim to create a hydraulic jump channel to explore this. Our initial research indicated that we could simulate this open channel by dropping a supercritical flow into a subcritical flow.
Supercritical flow is defined as having a Freud number greater than 1, whereas subcritical flow has a Freud number less than 1. Given our desired size for classroom demonstration and the flow rate we felt like was attainable, we used these parameters to design our demo.
With confidence in our calculations, we drafted a design using SolidWorks that could illustrate both safe and dangerous hydraulic jumps and constructed an acrylic channel. Here, we show a hydraulic jump that is considered safe for swimmers. The hydraulic jump is evident in the channel. Our measured jump is 0.65 inches, very close to what we calculated before. Sending a small kayak down the river shows that while the paddler may fall out of his kayak, he is washed downriver. As we change the angle of the channel, the dynamics of the flow changes. This is now a recirculating hole, which we predicted due to where the supercritical flow meets the subcritical flow, indicated by the red arrow. As the kayaker falls down the stream, he is sucked back into the recirculating hole.
Even dropping him into the water downstream, he can be sucked back up into the hole.
An example of this recirculation, seen often in rivers, is a low head dam. These recirculations are especially dangerous because they are uniform across the river, making them impossible to escape even from the side.
Because these types of flow can be so dangerous, many solutions have been introduced, including this solution proposed by researchers at Brigham Young University. Introducing turbulence below the drop or on the slope of the drop can help. We tried this type of solution within our own tank and found that it was effective in eliminating the recirculating current, thus making the channel much safer for kayakers.
To conclude, there are many types of hydraulic jumps that can occur in waterways. These jumps are caused by supercritical flow moving into subcritical flow and can be made more safe by introducing rocks and other debris to the channel.